Hello everyone. Today we're going to be graphing quadratics in standard form. So if we look at this first example, it says complete the table of values, then plot the coordinates to the graph of the equation y equals x squared. And so we have our x values right here, and we're just going to plug in to this equation, y equals x squared. So you can either do this using your brain or you can do it using a calculator, whichever is easier for you. And so for this first one, we see that y equals x squared. So y is going to equal negative 4 squared. Well, negative 4 squared is 16. This one will be negative 3 squared. Well, negative 3 squared is 9. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. And so we're just going to plot these points on our coordinate plane. And so I'm going to start by going to negative 4, and then 1, 2, 3, 4. So there's that one. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, 3, 9, and 4, 16. Once we have all those ordered pairs graphed, we're going to connect them to make a parabola. Remember that parabolas are U-shaped, not V-shaped. If we have a V-shaped function, that represents absolute value. And so you want to be sure that when you're graphing this parabola, that your bottom part, where your vertex is rounded like a U and not sharp like a V. So there you have it. We have graphed a parabola. Remember that the U-shaped curve is called a parabola, and that the turning point of the parabola is called the vertex. Our next question says, what is the vertex of example 1? Well, we can see that right here. This is our turning point, and so our vertex is at the origin, 0, 0. We can also see the turning point in our table of values, because if we look at our vertex, all of our numbers surrounding the vertex are repeating. And so that's how you know you have your vertex when you're looking at a table of values. It's because your numbers start to repeat. The next question says, what is the domain of the parabola graphed in example 1? Well, remember that your domain are your x values from left to right. So I'm going to scroll up to our graph. My furthest point to the left, well, it's an arrow, and it's going to keep going to the left forever. If I keep going to the left forever, I'm going to end up at negative infinity. My furthest point to the right, well, that's an arrow. I'm going to keep going to the right forever, and eventually I'll get to positive infinity. So my domain from left to right is from negative infinity to positive infinity. Or we could say all real numbers. This R with an extra line is the math symbol that represents all real numbers. The range of the parabola is our y values from the bottom of the graph to the top of the graph. And so if I scroll back up to our graph here, the bottom of my graph is my vertex. This is when y is 0. The top of my graph, well, that's going up forever. So that's going to infinity. So my range is from 0 to infinity. 0 gets a bracket because it is included, because it is on a solid line. Remember that your infinity symbols always get parentheses because as much as we want to, we can never get to infinity. We can keep counting forever, but we'll never end up there. We'll never be finished. Another way that we could write this is y is greater than or equal to 0. And that's because everything is above our vertex. So everything is greater than 0, and it's equal to because 0 is included. Our next question is, what is the root of the parabola graphed in example 1? Remember, root is just another name for an x-intercept. So our x-intercept is our vertex right there at 0, 0. And then we have, what is the axis of symmetry in example 1? Remember that the axis of symmetry is the same thing as the line of symmetry, and it is a vertical line that cuts the parabola into two symmetrical pieces, and it goes straight through the vertex. So here, my axis of symmetry is x equals 0. Remember, it will always be x equals the x coordinate of your vertex. So now let's go to the next page. On example 1, we were given the table of values already, and conveniently, the vertex was in the middle of our table. But what if we are just given an equation, and we have to come up with our own table of values? Well, there is a way to get the vertex when it is in standard form. Remember that standard form is y equals ax squared plus bx plus c. And so all the examples that we're going to look at today are going to be in standard form. So up at the top of our page, I have the steps for finding the vertex of an equation in standard form. So the x coordinate of the vertex will be negative b over 2a every time. Once you know the x coordinate of the vertex, you can plug that number into the equation to find the corresponding y coordinate, or you can use the table feature in a graphing calculator. So you could use like a TI-84, or you could use the app Desmos, but there are graphing calculators out there that can do this for you. The vertex will always be an ordered pair x, comma, y. So let's try this with example 1. So the first thing I'm going to do is I'm going to identify a, b, and c for y equals x squared plus 2x plus 1. So here a is 1, b is 2, and c is 1. Once I know that, I can go ahead and do negative b over 2a. And so I'll have negative 2 over 2 times 1. Negative times 2 is negative 2. 2 times 1 is 2. Negative 2 divided by 2 is negative 1. So this is the x coordinate of my vertex. And I like to put the vertex in the middle of my table. Well, once I know what the x coordinate is, I can know what my other x values are going to be because I'm just going to go in order. After negative 1 comes 0. After 0 comes positive 1. Before negative 1 is negative 2. And before negative 2 is negative 3. So from here, what you can do is you can plug in your x values in for x in the equation that you have here. And you can get your corresponding y values. Or you can use a table feature in your calculator. Whichever way is easier for you. When I plug these values in, for negative 3 I get 4, negative 2 I get 1, 0, 1, and 4. If you have done everything correctly, your numbers should repeat around your vertex. So that's just a quick way to check to make sure that you're doing it correctly. So I'm going to go ahead and plot these points. So I have negative 3, positive 4. -2, 1, -1, 0, 0, 1, and 1, 4. So I'm going to connect these points to create my parabola. Don't forget to include your arrows. And again, parabolas are U-shaped, not V-shaped. So you want to make sure it's curved where your vertex is and not pointed. So now I can go ahead and find the requested characteristics. They're asking me for the vertex. Well, we found the vertex right here. We can also see it right here on our graph. Our vertex is at, oops, sorry about that. Our vertex is at the ordered pair, -1, 0. Our domain are our x values from left to right. My graph is going to the left forever, so that's going to -infinity. My graph is going to the right forever, so that's going to +infinity. So my domain is from -infinity to +infinity, which is the same thing as all real numbers. Our range is our y values from the bottom of the graph to the top of the graph. The bottom of my graph is my vertex. Here, my y value is 0. And then my graph is going up forever. So my range is from 0 to infinity. Or I could say y is greater than or equal to 0. It's greater than because this curve is above my vertex. Now let's try example 3. We're going to do the same exact process. First thing that I'm going to do is identify A, B, and C. So here A is -1, B is 4, and C is -6. Once I know those things, I can go ahead and plug into -b over 2a to find the x-coordinate of my vertex. So I'll have -4 over 2 times 1. So that will be -4 over 2, which equals -2. Oops, this 1 should be a -1. And so that's going to be -2, making this a +2. So +2 there. So after 2 comes 3. After 3 comes 4. Before 2 is 1. And before 1 is 0. Once you know what x-coordinates you want, you can take these x-coordinates and plug them in for x in your equation. Or you can use a graphing calculator. When you do that, you should get the ordered pairs 0, -6, 1, -3, 2, -2, 3, -3, and 4, -6. So then we can go ahead and plot these points. So let's see. 1, -3, 2, -2. Here are my points. And now I'm going to connect these points to create a parabola. And I'm not going to forget to include my arrows. They want to know the vertex. Well, our vertex we found already was at the point 2, -2. Our domain is our x values from left to right. My graph is going to the left forever, so that's going to -infinity. My graph is going to the right forever, so that's going to +infinity. So my domain is from -infinity to +infinity. My range is my y values from the bottom of the graph to the top of the graph. The bottom of my graph is going down forever, so that's going to negative infinity. The top of my graph is my vertex, and that's where y is negative 2. So my range is from negative infinity to negative 2. Or we could say y is less than or equal to negative 2, because everything is below my vertex. For my range, or for my domain, instead of saying just negative infinity to positive infinity, you could have also have said all real numbers. What I would like you to do is go ahead and pause this video and see what you can do on examples 4 and 5. So go ahead and try those ones. So on example 4, first thing I'm going to do is identify A, B, and C. Here A is 5, B is negative 20, and C is 15. And so now I can plug in to negative B over 2A. And so when I do that, I'll have negative and then negative 20 over 2 times 5. Well, minus a negative becomes a positive because a negative times a negative is a positive. And 2 times 5 is 10. 20 divided by 10 is 2. So the x-coordinate of my vertex is 2. Then I'll have 3 and 4, and before that I'll have 1 and 0. Now that I know my x-coordinates, I can figure out my y-coordinates by plugging into my equation. And when I do that, my table looks like this. So now I'm going to go ahead and plot these points. Alright, once I have those points, I can connect them to create a parabola. There is my parabola. They want to know the vertex. The vertex is at the ordered pair to negative 5, which is right here. The domain is my x values from left to right. My graph is going to the left forever, so that's going to negative infinity. My graph is going to the right forever, so that's going to positive infinity. So my domain is from negative infinity to positive infinity, which is the same thing as all real numbers. Our range is our y values from the bottom of the graph to the top of the graph. The bottom of my graph is my vertex, and that's where y is negative 5. The top of my graph, well, this is going up forever, so that's going to infinity. So my range is from negative 5 to infinity. Or we could say y is greater than or equal to negative 5. Our line of symmetry is a line that cuts our parabola into 2 equal pieces. It is a vertical line and it goes straight through the vertex. And so my line of symmetry in this case is going to be x equals 2. Remember, it's always x equals the x-coordinate of your vertex. And then they also want to know the y-intercept. Here, our y-intercept we can see on our graph, and we can also see it in our table. Our y-intercept is the ordered pair 0, 15. On number 5, the first thing I'm going to do is identify A, B, and C. Here A is 2, B is negative 4, and C is 7. So I'm going to do negative B over 2A and have negative, negative 4, over 2 times 2. And so I'll have positive 4 over 4, which is 1. So 1 is the number that is going to go for my x coordinate of my vertex. After 1 comes 2, and then 3. Before 1 is 0, and negative 1. And when you find your corresponding f of x values, you get 13, 7, 5, 7, and 13. So I'm going to go ahead and plot these points. So let's see, 1, 2, 3. And I have 1, 2, 3, 4, 5. Once you get the vertex, the rest is symmetrical, so it goes a little bit faster. And then I'm going to connect these to make our parabola. There we go. The vertex is at the ordered pair 1, 5. Our domain are our x values from left to right, or we could say from least to greatest. And so I can see that my graph is going to the left forever. So that's going to negative infinity. And it's going to the right forever. So that's going to positive infinity. So my domain is from negative infinity to positive infinity, which is the same thing as all real numbers. Our range is our y values from the bottom of our graph to the top of our graph. The bottom of our graph is our vertex, and that is where y is 5. Our graph is going up forever, so that's going to infinity. So our range is from 5 to infinity, which is the same thing as y is greater than 5. Is our vertex a maximum or a minimum? Well, our vertex is the lowest point of our graph, so that makes this one a minimum. And then here we want to know our zeros. Remember, zeros are the same thing as x-intercepts. When we look at our graph, it does not cross the x-axis, and it will never. How do I know this? Well, I know this because my graph is going up in both directions. It's never going to come back down and cross that x-axis. It's never going to get lower than our minimum value of our vertex. So I do not have any x-intercepts. So that means I do not have any zeros. So we would just write none. And so if you were solving this quadratic equation, you would get no real solutions when you were to solve it. We have one more example to go over together today, and this is example 6. It says, Donnie the droid is crossing a bridge over a river and decides to throw a rock into the air so that it will fall into the river below. The distance of the rock above the water can be modeled by h of t equals negative 16t squared plus 96t plus 112. Where h of t is the height of the rock in feet and t is the time in seconds. So part A is to draw a visual representation of the event. So this is just asking us to draw a picture. So here is Donnie the droid. He is on a bridge. Below the bridge is the water. And so what he is doing is he is taking a rock, he's throwing it up into the air, and then it's going to crash into the water below. And so this is a picture of the event. When we graph this, we're doing the same thing that we just did. We're drawing a picture of what is happening. And when we put it on a coordinate plane, we're now including how high it is in terms of the feet and at what point in time the rock is. So after 2 seconds, where is the rock? After 4 seconds, where is the rock? And so the coordinate plane just puts this picture into like a more accurate representation. So let's go ahead and do that. Part B, graph the function and label the axes. So here, this is my t-axis. It represents time in seconds, and they tell us that in the problem. Here is h of t, and it represents the height in feet. And again, they tell us that in the problem. So the first thing I want to do is I want to figure out where my vertex is going to be. So I'm going to do negative b over 2a. Again, here is the function that we're looking at. So here a is negative 16, b is 96, and c is 112. So I'm going to have negative 96 over 2 times negative 16. So that will give me negative 96 over negative 32, which equals positive 3. When we have a real life situation, we want to start at the beginning of the problem, right? I don't want to start like right here in the problem. I want to start when the rock leaves Donnie the droid's hand. And so that's going to happen when time is 0, right? We don't have negative time. So the beginning of this event is when time is 0. And I know the vertex, so this part over here, that's going to be after 3 seconds. So we at least need to get to 3. And then I want to keep going until the event is over. So I want to go until when the rock hits the water. And so that is going to be when the height is 0, because now it's in the water. Think about it like it being on the ground. And so when it hits the water, it's done. And so we'll have to keep going until we get to 0 for our height. And we're just going to have to plug into our calculator and keep going until we can figure out where that is. So let's see. When time is 0, our height is 112. And all I'm doing is just plugging in our values for t into our equation. When after 1 second, the height is 192 feet. After 2 seconds, we're at 240 feet. After 3 seconds, we're at 256 feet. After 4 seconds, we're at 240. After 5 seconds, we are at 192. After 6 seconds, we're at 112. So right now, everything we can see is like lining up, right? So, for example, here's my vertex. And then I can see surrounding my vertex, like these are together, and these are together. And so far, whenever we've graphed parabolas, we've had them be perfectly symmetrical. But if we look at this one doesn't look perfectly symmetrical. And that's because we didn't start on the ground, right? We didn't throw the rock up when we were in the water. And so this real life event isn't going to be symmetrical, and that's okay. So if I find after 7 seconds where the rock hits the water, that's when it's at 0. And so this hits the water after 7 seconds. So now I know the whole event. We know how high it was at the start, and we know how long it took until it hit the water. And so we're just going to graph that on this coordinate plane. And so I'm going to go ahead and plot those points. 192, 240, 3, 256, and so when I graph this, this is what my parabola looks like. So this is the visual representation of this event, but now we know exactly what height and what time the rock is in each position. If we look at part C, it says, what is the rock's maximum height? Well, the maximum height is going to be the vertex. And so this point right here, we know is the point 3, 256. 3 represents 3 seconds. 256 represents the height in feet. So the rock's maximum height is 256 feet. And then it says, after how many seconds does the rock reach its maximum height? Well, that's after 3 seconds. And we can get that just by looking at our table of values. Part D, when does the rock hit the water? Well, the rock hits the water when time is 0, or when the height is 0. And h of t is 0 after 7 seconds. Part E, how long is the rock in the air before it reaches its maximum height? So how long is the rock's height increasing? Well, let's see. We are increasing from the start of the event, from the start of the event up until the vertex. And then we're decreasing from the vertex to the end. So it might help if I go ahead and draw my line of symmetry in here. All right, so again, we're increasing from the beginning to the vertex. So if we look at this, we are increasing from here to here. So that is from 0 to 3. So we are increasing for 3 seconds. Part F. After the rock reaches its maximum height, how long does it take to hit the water? In other words, how long is the rock's height decreasing? So the rock's height is decreasing from the vertex till the end. So it's decreasing from 3 seconds to 7 seconds. Well, from 3 to 7, that is 4 seconds. So the rock's height is decreasing for 4 seconds. Part G. How high from the river was the bridge that Donnie the droid was walking on? So we want to know, how high is this bridge? Well, let's see. That would be from when time is 0, right? Because before the rock leaves his hand, that's the initial height. And so our initial height is 112 feet.